Okay, so yeah, so for those at home, make sure that you realize it's midterm this week. So by Friday this week, we have a test this Friday, so keep that in mind. I probably won't enter it until after midterm, so it's not affecting your midterm grade too much. That way you can get a chance to retake it. But we are taking a test this Friday, so if you're going to be at home, that'd be probably you guys here if you're at home. Zoom in. Basically what I'm going to do is I'm going to share the test with you on screen, and then you'll just do it on a separate sheet of paper. And then you'll take a picture of it and email it, or you'll send it to me via Google Classroom instantly. So, and I want that on camera. Just a reminder, like what I talked about last Friday, was you got to put your camera in such a position that I can see your hands at all times. I don't really care about seeing your face. That's fine in the beginning to see that you're the actual one taking the test, but I do want to see your hands, so I can see what you're actually taking the test. I don't need to see your answers, because I don't want your neighbors, on the Zoom to see your answers. But I do need to see that you're working, that your hands aren't going out of focus, that they're, your cell phone is nowhere near you, and then you have to have your microphone unmuted. So put yourself in a very quiet position. The reason why I need to make sure there's no sound going on and whatnot. But yeah, so there's lots of little things. So keep that in mind, and I'll probably ask you a question right in the beginning to see how you're doing and whatnot, and see if you're ready. You need a calculator, so make sure you have one. So, but yeah, so that's coming up this Friday. We'll start reviewing probably on Wednesday this week. We'll do a 2-day review like we always do. I will not have vocabulary in this test. There'll be no vocab. So I'll be just pretty much straight to work. Make sure you have your property sheet for Algebra 1. The ones with the properties like commutative, distributive, that type of thing that's on this test. So keep that in mind. I think you have a couple of those you have to do. You have to show me the work, simplify it. So there's quite a bit of points there, so keep that in mind. There's a couple things with sequences. There's some stuff with graphing, there's some stuff with systems, and then the stuff we do today, which is on reasoning again. So I know we've talked about inductive and deductive reasoning, but now we're going to be applying it, really. That's the title of this unit, was deductive reasoning. So, all right, questions though. Okay, so yeah, so we'll get started here. You can see my iPad screen. Hopefully everyone at home can hopefully hear me and see me. So I'm gonna take attendance here. I'm sure I'm gonna submit attendance and somebody's gonna come in 2 seconds later. It's about to happen, I bet. For those at home, can you guys see my iPad? Are you guys seeing attendance? What are you guys seeing? Should be sharing my... Oh, I lost. There's Alexis again? Man, she must be having computer issues. I just took it. Yeah, must be having computer issues. Okay, so all right, we'll get started here. Just a reminder, we have homework due tomorrow. It was on Google Classroom, so make sure you're filling that out. That is the worksheet that we had on. It was on substitution method. There was no special cases on that, so keep that in mind. Special cases could be on the test where there's a no solution or infinite solution. We'll probably review that on probably Thursday this week. That'll be all the system stuff, and then obviously the stuff that we do today. So, all right, we have 2 words today that I want to discuss. So that's what I want to get to today. Let's get rid of these. We don't need those. All right. So, okay, there's a couple vocab words here that I want to discuss. That's odd. Did I hit the screen at that point? There we go. Okay. All right. So section 2.9, we're on reasoning. We've been talking about reasoning since the beginning of this chapter. Deductive and inductive. Deductive is just pure memorization. That's kind of nice to have. You can recall knowledge. You can spit it out. But inductive is where you have to look at patterns and observations and kind of learn from it. You got to learn on the fly. You got to have both. it's nice to memorize and kind of learn, but it's also nice that you can adapt and adjust to things. Well, today we have 2 new topics, so you're really going to have to adjust pretty quick. We have conjunctions and disjunctions. So the 2 types are very, very different types of conditional statements. So if you don't know what a conditional statement is, a conditional statement is using if and then. So let me give you an example of a conditional statement. If it is windy, then I will wear a jacket. Ooh, I just spelled jacket wrong. How embarrassing. Jacket. Okay, there. Hopefully you guys can see that. That's a conditional statement. It's using if and then. What you're going to see in these next couple units that we're doing, Unit 4, Unit 5, we're going to be doing a lot more conditional statements. This is something that will not go away. It's kind of nice that this unit kind of does a nice review of the different types of reasoning. Kind of gives you that sense, but it also does a little bit of vocab. It's always the last section of my Unit 3 that I always like to cover. I think it's pretty straightforward when you get going, but what a conjunction and disjunction is in a conditional statement, they could use the words and or. And it's just this way of comparing, right? So let me give you the words here. So a conjunction uses the word and a disjunction uses the word or in a sentence. So like for instance, if I use an if-then statement, so if you signed up for hot lunch today, they're serving hamburgers and milk, right? So there's a conditional statement there. It's an if. If this, hypothetically, if you were to sign up for hot lunch today, then that's the conclusion. Then you're getting hamburgers and milk, right? What does the word and mean in general? Like just in general, what does and mean? Say it again? Also, right? They're serving both at the same time, correct? Like it's not one or the other. It's not, it's not going to be like hamburgers or salad bar, right? It's an and problem. Hamburgers and milk. They have to have both on the tray to be considered a true statement. A disjunction would be or. That's the example I just showed. Like if you're going to sign for hamburgers or salad bar. Well, that's an or. It's one or the other. One has to be true. So maybe they ran out of hamburgers, so they're just serving salads. Okay, well, they're still true. That's still a true statement because they had the word or there. It didn't have to be both. It was just one or the other. So it's one of those things like when you put it in terms of realistic like concepts, like it makes a lot of sense. It's an and or problem. So what we're going to look at is we're going to look at how to do what they call a truth table. Are they telling the truth on a conditional statement? Are they telling the truth with an and or an or, a disjunction, a conjunction? But I'm just going to talk about the basics today. We're not going to do any weird like English sentences and breaking down and looking at the different parts of a sentence. I'll save that for English class. I'm not an English major. I'll leave that to them. I just want to talk about it in terms of math. Like, what is the probability that they're telling the truth? Probability, if you don't know, is the likelihood of an event occurring, right? It's a part of statistics. That's a class that you are offered, your junior or senior year in here. And it's this idea that, there's a lot of forms to statistics, but it's looking at the data. Does the data give you the option of that event occurring? And so that's the probability. That's what we're going to look at for this. Now, conjunction and disjunction. I said it's the word and or, right? There's a mathematical symbol for it. For and or. That's the symbols we're going to use today. So you get very, very used to this. So the symbol that you need to know is this. For an and problem. Okay. That's the symbol for an and. It is a little up arrow key. It's like a little, it's right above the 6 key on a QWERTY keyboard, right? It's a little up arrow. It's an exponent key on a keyboard. So when you want to type an exponent, you could substitute that symbol in for the word and. So I'll put little air quotes around it. So something and something. It's just this little shorthand symbol for it. And then for the word or, it is a down arrow. Like almost a V-looking shape. So they put that between 2 mathematical statements. That's just something you need to get used to. They do this a lot in like pre-calc and a calc course. They would put that symbol, and a lot of people don't know what they mean. It means and or. So one or the other. So that's what we're going to look at now. How do I memorize it? Because that's the hard part. It's like, oh man, how do you know which one's which? Because that when you're out there and they just put it in front of me, like, I don't know how to memorize that. Here's how I do it, and this is totally silly. Hopefully this makes sense to you. This is how I memorized it. Okay, the little up arrow symbol, right? I just told you that was the word and, right? It looks like an N. It looks like an N for and. That's how I think of it. And then the word or, like that. It looks like somebody wrote a really bad R. Like where they put a tail on it. Really bad R. I know it's really dumb. That's how I memorize it. And an or. So the little up arrow key looks like an N, and the down arrow looks like a really bad R if you're writing it. So I know it's stupid. That's how I memorize it. So, but anyway, let's go to the truth table. Let's talk about this mathematical idea of a reasoning. What's the likelihood of this event occurring or being a true statement, right? Okay, so I have 3 statements here. I don't care if they're true or false. Doesn't really matter. There's just 3 sentences. In fact, I don't even need to give you the sentences. You don't need to see these 3 things written down. You just need to have, the symbols. So we're going to look at a truth table and look at the likelihood of an event occurring. I'll come back to these sentences here in a second, to talk about if this is a true or a false statement. We'll come back to that. I just provided 3 sentences that we could actually look at the validity of them. Validity means truth. Okay, so the 3 sentences, there are 30 days in November, a rectangle contains 4 right angles, and the third sentence is all angles in a triangle sum to be 360. I don't know if any of those are true or false, don't really care, we'll look at them in a little bit. Let's actually look at a truth table. So, we'll come back to those sentences here in a second. I know that seems weird, I just provided you 3 sentences. Okay, so here's what I'm talking about. Let's talk about this statement. Talk about this statement just by itself. Okay, if we were to say this mathematical statement out loud, it would be A and B, right? That's that little symbol. For this sentence to be true, in terms of mathematics, both have to be true. Because the word and means both. Okay, it means both at the same time. They both have to be true. But if we look at the mathematics behind it, like the probability of this being a true statement, you have to set up what they call a truth table. It's this idea of using reasoning. So you got to memorize the word and what the symbol is. But then for the truth table is you use your inductive reasoning and you come up with a logical conclusion. It's an idea where you have to really use this idea, this concept that you make an educated, not a guess, but an educated breakdown of every possible combination that could happen here. So here's what I like you to do. I like you to make a column or a grid where there's 3 columns. 3 columns. Now you're probably wondering, why are we doing 3 columns? That seems weird. This is called a truth table. Well, on a truth table, what you have to do is you have to provide a column for every single variable that you see. So in this problem, how many different letters do we see? 2, A and a B, correct? So we have an A and a B. So we put A here and we put a B here. Okay? My wrist is really activating the screen today. Usually it doesn't do that. So we have an A and a B. In the third column, you put the solution of what they're looking for, the probability of the likelihood of this event occurring. We're looking for this answer. We're looking for that. A and B. In fact, I'm going to put the word and there just so you can see that. A and B. I like to put that little symbol in there so you know it. Okay, so without knowing sentence A and B, I'll go back to the last slide here in a second. That where I had the three sentences. I'll go back to it here in a second. There's a combination that could happen here without it even having read the sentences or really breaking them down. A could be true. Do you agree? A could be true. Yeah. Okay, or it could be false. There is the likelihood of true and false there. I don't know. We'll go back to look at A. B could also be true. but it also could be false. But then there's another combination here. Well, it could be maybe the first one is true and the second one is false, or maybe the first sentence is false and that second one is true. That's my combinations I can possibly have. I could have A could be true and B could be true. It could be a true and a false and false, or a false and a true. Those are every possible combination for my true sentences without even having read them for the likelihood for being true and false at the same time. Now, for the last column, for the and, what was the key word that I said for and earlier? Both. Both have to be true for and to work. So if the cooks at the lunch ladies at the lunch, if they served hamburgers and milk, both better be on the tray, right? That's how it's a true statement. If one of them's gone, they lied, right? It's a false statement. So what we look at, are both true here and here? Yes, they are. So the and part would be true. Both worked. They were true and true. Both works. Are they both true right here? No, so that's a false statement automatically. For the word and, you cannot have a false. You cannot have a false. If one of the things didn't occur, then it's not true. Are these both true? Well, definitely not. They're both false, so it's automatically a false statement. And the last one, are these both true? No. So that's a false statement. One of them was false. So for the word and, both have to work. Now, what I'm looking at here in the very end is I'm looking at the mathematics back here. I'm looking at this statement. And I'm breaking those down. And I look at that last column, because that's what we're looking at. And I look at what is the likelihood of getting a true out of this sentence. Well, how many possible combinations did we have? We had 4, right? We had 4 possible combinations that could happen. Okay. The likelihood of it being true was 1 out of 4 that this was true. That this was true. 3 out of 4 that this was going to be a false statement. So if you're a betting person, is this probably going to be a true or false sentence? Probably going to be a false if you're into betting at all, right? Because it was 75% likelihood that my sentence, without even having read it yet, but I'll go back to those sentences here in a minute. I haven't even broke them down yet. The likelihood of this being true is really low, like exceptionally low. Now it could be true. Don't get me wrong. There's 25% chance that this is a true sentence, but this is what they call a truth table. You can break down the mathematical sentences that they give you to figure out if it's true or false without even knowing what the mathematical statement says. So it's using a little bit of reasoning here. So let's go back to the sentences. So, okay, so we're using A and B, right? Those are the 2 sentences I picked at random, A and B. So is this true? So is this first sentence, is that true? Are there 30 days in November? Yeah, there is. That is true. Now, if you don't know, there is this rule. It's called the Knuckle Rule. And that's a picture of a hand. Sorry, that's my hand. And then here's another picture of a hand going the other way. All right. And what you do is you count the knuckles and the valleys between to figure out if you have that many days of the month. I don't know if you ever did this in elementary days. So January starts here. If you're on a knuckle top, then you have 31 days on a calendar. So that's January. February does not. It's in a valley. So February is a no. March is a yes. April's a no. May. June is no, and July is yes. So far you can tell if they have 30 or 31 days by if they land on a knuckle top. And then when you go to the next hand, you ignore your thumb. Go to the next hand. This is August. August does. October doesn't. September doesn't. October does. November doesn't. And December does. So November, it doesn't have 31, so it has 30, so that's a true statement. I know that's really dumb, sorry. It's just what you have to look at. Now, next part. A rectangle contains 4 right angles, true or false? True. That is a true statement. That's literally the definition of of a rectangle. It has 4 right angles in it. It's a quad, a parallelogram that contains 4 right angles. So both were true. So if I go back to my last slide here, which column we ended up with was this one. They were both true. A was true, B was true, and so my overall sentence in the very, very end, my overall sentence was a true statement.
Mr. Ward.
Yes.
I don't think we can see the screen.
Did it just suddenly quit, or did it not work for a very long time?
You cut out for a while and then it turned off, but now it's back on.
Weird. Okay. Well, thanks for telling me. Here, I'll leave that. Can you guys see that? Yeah. You know?
Yeah.
Yeah. Okay. Good. I'll leave that up there. So, so going back to that last one. So well, that's weird. I didn't even notice. Sorry. Go back to that last sentence. I'll take screenshots of the stuff that I was showing you. All right. Yeah, so this is the truth table. So we ended up with both sentences were true, so the likelihood of that event being true was 25% chance that it was a true sentence. We'll do another one here. We'll do another one. So we'll do it for the same A and B. Okay, let me go back, sorry, so you guys can write that down. Okay, let's do another truth table, and you guys can pick it for A, B, and C. I had 3 sentences earlier. We'll use the same 3 sentences. You can put and or in between them. So pick any 2 you want. A, B, or C. Pick any 2.
C.
C and?
B.
B. Okay, let's go C and B. Now, do we want to put an and between it or an or? Or. Okay, let's do that. Okay, so we'll go to the next slide here. If you guys at home are watching the Zoom, maybe you want to take a screenshot real quick. I don't know. Maybe you already have it. I'll put it back here later. Okay, so let's go B. You said C and B, right? C or B. So C or B. There we go. So we're doing the mathematical sentence. This is the word or. That's what this little V symbol means. It's the word or. So it's one or the other. That's kind of the idea that I think of, one or the other. So if one of the things is true, it's automatically a true sentence. So the cooks could serve hamburgers or salad bar, that type of thing. So if one of them's on your tray, they didn't lie to you. It's one or the other. But let's do a truth table for it. So very, very different, right? Going back to this idea of reasoning. Okay, so how many columns do we need on this one? How many different variables do we have? We have 2 variables and we have that last one, so we need a total of 3. So we're gonna have 3 columns just like we did before. 3 columns. So we're gonna have a C column. Let me put that in the front. So we have a C column, we have a B column, and then the last column is C or B. A little up arrow key, or I guess down arrow, a little V symbol between them. So we have 3 columns because we have 2 letters and then the answer we're looking for. Tomorrow we're going to look at more complicated ones of these. So. Okay, so let's make the likelihood of this, let's make every combination here of trues. So without even going back and reading the sentences, I know we read the first 2, I didn't really look at what the third one was, I don't remember it. So looking at this, here's the possible combinations that could happen. They could both be true. One could be true, like that, or they could both be false. Does everyone agree those are the possible combinations that could happen? They could both be true, one could be true, flip-flop them, and they could both be false. Now, if that's the likelihood of this, these sentences, these mathematical sentences being told to us, we're going to look at the last column, which is, this is an or column, right? That weird symbol is the or symbol, the little down arrow key. So that's an or. So if one of them is true, it's automatically true in this last column. So are one of these true? Well, yeah, duh, they're both true, so it's true in the last column. Is one of these true? Yes, that's automatically a true. Are one of these true? Yes, so that's true. Are one of these true? No, that's a false. So the mathematical likelihood that this is a true sentence is 3 out of 4 that this will be truth. And then there's 1 out of 4 chances that this sentence will be false when I compare both mathematical sentences. So it's very important that when you say and or, you actually know what you're talking about. So it's probably better to say the word or when you're actually using the sentences, but don't tell that to the English department. One or the other. Well, let's go back and let's look at the sentences here. I know a lot of you are writing this down. 75% likelihood, without even having read C and B, I can tell you the truth of this sentence. Just because of the word or. Again, very kind of weird stuff. Very, very different pacing compared to what we did last week. Like, if you think about it, like we were doing algebra stuff last week, and suddenly now we're jumping all the way back to reasoning again. Back to the beginning of this unit. Coming full circle. Looking at true and false sentences. All right, let's go back and let's look at the sentences. So we picked C and B. Those are the two that we chose. Okay. So C and B. These are the two sentences that we chose earlier. So let me, I think I got a picture of this earlier. I'm pretty sure I did. All right. Pick a bigger eraser. All right, so we're picking C and B. Let me get rid of that. So, all right. So these are the two we're picking. We already said that this one was true. So, okay, perfect. That was true. And there's right angles. What about the next one? All angles in a triangle sum up to be 360. True or false? This is in the last unit we did.
False.
False. Why?
Because there is no angles.
Say it again.
There is no angles.
In a triangle? There's 3.
Oh wait. I thought it said circle.
No. In a triangle. It is false, but why? What do triangles have to add up to be? My chat window popped up. So those at home, you can type in the chat. What do the triangles have to add up to be again? 180, yeah. That was something we talked about the last unit. We did, yeah. So triangles have to add up to be 180. So we have a true and a false here. So if we go back to that, that slide again, looking at the probability of this being true, the first sentence B was true. All right, so we're either here or here. And C was false, so C ended up being a false sentence that it didn't add to be 360. So it was actually this statement right here. Right, that was my sentence. So the overall answer to that sentence, it ended up being a true. So the sentence I told you was truth. Kind of weird things when you start to think about, like, you're thinking like, wow, this is a very weird departure from what we did last week. Just put it in terms of like what we were discussing last week. We were doing systems, right? Looking at, can we find a common solution to a system, or was it a special case? So one or the other. If it was a special case, there's 2 options there. It could have been an infinite solution or a no solution. So there's always 3 possible outcomes on a system. And that's the type of problem we were looking at last week. Well, now we're looking at like breaking it down in terms of mathematical sentences. And this is the final unit of this deductive reasoning unit, which is based on a lot of algebra and probability and stuff. So yeah, kind of weird stuff. It's kind of a weird mix. Questions with kind of the new topics we've been talking about. Okay, I know this is a radical departure, right? This is stuff we have never seen before. It's kind of new. We're going to look at this stuff again tomorrow. Tomorrow I'm going to do a couple more of these. I have a couple more sentences we can pick, but I'm going to make them maybe a little more difficult. So tomorrow, bring your notes for sure. Even those at home, I want you to actively participate tomorrow, where I'm going to ask you to make a truth table for a sentence that we do. See, the likelihood of it being true or false, and then we're going to make some really complicated ones where we're going to throw in some new vocab terms tomorrow. I thought today was a nice intro day into it. But questions? Questions with any of the stuff I've set up? Hopefully that made sense to you today. It's very, very
Is
weird.
this stuff going to be on the test?
Yes, it'll be one of the last questions on the test. So it's our last sections. We'll cover this today and tomorrow. Okay, but again, good reminder. We have tests this Friday, so keep that in mind. End of midterm is this Friday, so the test will not be in this midterm. I'll probably enter it into next midterm, so you can take a retake if you want. All late work is due by the end of this week. We have homework assignment due tomorrow. That was on systems and substitution, so make sure you're doing that. I think there was no special cases on that. They should all have a nice clean answer. So if you have not submitted those, do that now, or it's due by tomorrow night by 11:59 p.m. And yeah, there you go. Okay, we're done for the day. So for those at home, you guys can go answer the Google form question of the day. So go take care of that. I've submitted it. I think it went out earlier. It was, what are the symbols we use for disjunctions and conjunctions? So there you go. I'll go back. There you go. There's your symbols.